The next rule is the quotient rule. So this rule states that if I'm dividing the same base by each other, I can actually subtract the two exponents. So x to the a over x to the b would be x to the a minus b. So an example would be like x to the third over x squared. Well, we know if we expanded it, it'd be x times x over x times x, and anything else over itself cancels, so we're really canceling out these sets, and we're left with x to the first power. So that came from subtracting the 3 over the 2. So we know the shortcut now is to just subtract the top minus the bottom, and we get x to the first power. Well, what if it had been upside down? What if I had something where there's more on the bottom than there is on top? So if I've got something like x to the second power over x to the fourth power, well, I would only have 2 x's on top, but I'd have 4 on bottom. So when they cancel, there's 2 left, but they're on the bottom. Well, I can't just say x squared, because that's saying like it's on top. There's got to be a 1 placeholder. Additionally, some people would say x to the 2 minus 4, and that would give us x to the negative 2. Well, these two things actually mean the same thing. In a little bit, we're going to talk about this negative exponent rule, but when we have a negative exponent, essentially it's because it's out of place. Right now it's on top in the numerator, and we know from this example it really belongs in the denominator. So some more with the quotient rule. If I have some actual numbers, some coefficients, I have to watch out. For example, if I have something like 27 x cubed y to the fourth over 9x y squared, I've got to make sure I'm not subtracting these normal numbers. I'm actually doing 27 over 9, which divides out to give me 3. Then with the understood one here, got to watch out for that as well. I'm going to do x cubed over x to the first gives me x to the second when I subtract. Y to the fourth over y to the second gives me y to the second when I subtract. And then that would be our final answer. Sometimes you can't divide out the numbers, they'll only reduce. So for example, if I have something like 4x cubed y over 12x squared y, 4 over 12 doesn't become 3, it becomes 1/3. X cubed over x squared will leave me just x to the first, and honestly this y to the first over y to the first ends up canceling each other out, and so there's no y in the final answer. Our answer would just be 1/3 x. That would be the final answer if I reduced it all the way. So your two examples for the quotient rule, we got 27x to the fifth over 42x. I'm looking at 27 and 42 and I'm trying to think what will go into both. So I think of the factors of 27, I know 9 and 3, then we think of 42 and I know that it's going to be at least 3. So if I reduce them both by 3, I'm actually left with 9/14. Now that's not something that's very common. We don't really try and think of what 42 divided by 3 is, but you need to be aware of reducing this if it reduces. Now the x's are going to be easy. I just got to remember there's an understood one here, and so x to the fifth over x to the first leaves us with x to the fourth. On example number 2, we're going to do our power rule on top, and then we're going to use our quotient rule. So y to the 2 times 2 to the second power is going to give us y to the fourth. And that's over y to the fourth. And anything over itself ends up just being 1. What we're actually about to see here at the end of this lesson, that there's also another thing happening here. If we were to use this quotient rule and do y to the fourth minus y to the fourth, we get y to the 0. And this is going to be proven a little bit later that anything to the 0 power is actually just 1.